themselves and not have to deal with it at all. Like we did the other day when we had that, 10, 5, and 2 for denominators, multiply the entire thing by 10. Here, I'm just multiplying everything by 12. By doing that, it eliminates all of your fractions. You don't have to do anything with that. Okay? So if you multiply everything here by 12, 12 times 2 gives you a 24. X plus 5 quantity squared. 12 over 3 is what? 4. So 4 times 2 is 8. 12 over 4 is 3. 3 times 3n is 9. Okay. So far, so good? Okay. Subtract 8, divide by 24. X plus 5 quantity squared equals 1 over 24. Okay. Square root of both sides. So when you square root both sides, we're going to get x plus 5 equals plus or minus. Now, one of the things that I like to do whenever I have to do a fraction square root, I'm going to put the square root symbol in both parts, because that way I remember that I have to do both parts, and not use /e fractions. And what's the square root of 1? What's the square root of 24? Very good. 2 root 6. Good. So now I get, move this up here, I'm going to get plus or minus 1 over 2 root 6. Now, in the past few days, when people have been rationalizing their denominators, a couple people have been doing things an easy way, and a couple people have been doing things the hard way. The easy way to eliminate my root here is just to rationalize by the root 6. Just multiply top and bottom by root 6. Some of you guys have been multiplying top and bottom by 2 root 6. Well, that's fine. It's just a larger number, and then you just have to simplify the fraction later. Here, if you just multiply top by root 6, it's just a little bit easier. Because what's the square root of 6 times the square root of 6? 6. Now what's 2 times 6? 12. So I get plus or minus root 6 over 12, and then with that 5 that was here, I just move it out in front. Now, I think I've said this before, sometimes textbooks or sometimes answer guides, they might put these two with the common denominator. I don't know if you guys came across anything like that. You don't have to. I'm not worrying about common denominator here, okay? So you can just leave it as that, and you're done. If you multiply by 2 root 6 over 2 root 6, you would have gotten 2 root 6 over 24, and then the 2 and the 24 would have simplified. Hopefully you would have noticed that. But again, these are going to be numbers that I'm setting up for you guys that you don't need to freak out about. I mean, even the 3/4 and the 2/3 multiplied by 12, they're gone. Don't worry. All right? Just take a deep breath and, okay, where's my denominator? What other ones do you want to look at on that? What are you going to multiply it by? 6. Exactly. Once you multiply that whole thing by 6, what happens? Everything goes away, doesn't it? Yeah. So what becomes the numerator in that in your first fraction then? 2. Good. Very good. If you multiply this whole thing by 6, you're going to get 2 times the quantity x minus 1 quantity squared. 6 over this is 1. And the other one is 5. Again, see how fast that is, even with the fraction. It's this one's very similar to that one we did yesterday with the 10, the 5, and the 2. Okay. Subtract 1, divide by 2, you get. Sorry, subtracting 1, saying this, and I forgot to divide. That's 2. I'm SMRT. And your answer will be, hopefully you got 1 plus or minus root 2. Super exciting. It's fun, isn't it? Yes, sir. How did I get the 2? What's 6 divided by 3? Yeah, remember what you're doing here with this 6 is that you're distributing it to each piece within the whole thing. So then you get 6 over 3, 6 times 1 over 6, 6 times 5 over 6. And that's how the fractions themselves simplify out. That way you eliminate all your denominators. Okay? Bless you. I'm trying to think if there's any other weird fraction. Not really. If you look at 14, it's on the left-hand column there. It's the 2/3 x squared minus 8 is 16. Just a reminder of how this works. What do you do first? Add the 8. Good. So if you add the 8 over, we get 2/3 x squared is 24. Now, to undo that 2/3, you have to multiply it by 3/2. So if you multiply both sides by 3/2, even though it's a fraction, remember what this means. 24 times 3, all divided by 2. Or, what's 24 divided by 2? Multiply that by 3. Math. And then what do? Square root it, you get a plus minus 6. Oops. Okay. Even though the fraction is there, the fractional values that you will see will not be 11/7 or 17/3, or will they? All right, it's that straightforward with those. Okay, are we decent-ish now with equations? Just working backwards. Okay. If are there any others that you can think of that you're just looking at it and you just want to make sure that you know how to set it up before I flip over and talk about graphing and factoring? Yes, ma'am. Which one was that? Let's pull this up then. Let's take a look.
On the right.
Oh, I see it. Do. Yeah, she's looking at the one with both of them on the other side there. Oop, that didn't work. That worked. There it goes. Okay. So when I first looked at your page, I couldn't tell if it was a squared term on the inside here. I thought that was squared. That's why I wanted to make sure it wasn't it. On this one here, you would in fact distribute the 3 into the parentheses because it's not squared. If it was something squared, you can't distribute it. Does that make sense? So here I can do that, go in there and do that. So I got 3x squared minus 12 is 2x squared minus 1. Now you got variables on both sides of the equation. Work our way backwards. Bring the 2x over, put the 12 the other way. Plus or minus root 11. I looked a lot worse than it was going to. Yeah, no, and guys, remember, you can distribute this one until it does this. Then you can't. Because the x1 rule tells you to take care of your x1 before you multiply. You're just going to throw it in operations. Yes, sir. What's that? If it was squared, you would have to, if it was squared, the only way this would work if this was a squared term is that this probably wouldn't be there for now. And then you'd have to multiply it out and FOIL it. And then you'd have to subtract, then you would distribute the 3, then you would subtract over, and it just becomes a longer problem. Okay? You would have to follow your order of operations before you can work backwards. Does that make sense? It doesn't, I don't think we are going to see anything like that at all right now. Okay? That's a good question. So I wouldn't worry. I'm going to do my Chris Farley dance. The van out by the river. What? With the top? Yeah, the only number 6. Okay. It's what happens when you piecemeal something together, you know what number you're looking at. Because there's so there I could have had multiple sixes. All right. So let's see here. In this case, I would subtract 3, divide by -2. You okay with that as a start? All right. So I subtract 3 divided by -2. I'm going to get x minus 1 quantity squared equals -3/2. We okay with that? Okay. Now, when I take my square root, since there's a negative, that means we're going to have what in our answer? An I. Very good. So if you want to do that to start, we know it's going to be x can equal 1 plus or minus. There's going to be an I in it. And then just write down √3 over √2. By doing it this way, you've already alleviated the problem that you know that you're going to have an imaginary number. You've taken it out. And now you can just rationalize it like you would. What are you going to multiply top and bottom on that? Perfect. If I multiply top and bottom by √2, what's your numerator going to become? Excellent. So your final, I'm sorry, were you guys okay with me moving the 1 and doing all that in one step? Was that okay? I didn't mean to, I just kind of said it really quick, and nobody said anything about it. Was everybody okay with that? I just kind of skipped a few things. So now your final answer then would be x equals 1 plus or minus I √6 all over 2. Just that portion. Not too terrible then? What'd I do? Yeah, eyes up on top, yeah. Yep. Yeah. Because remember, when you have a negative fraction, it's either the numerator or the denominator, it doesn't matter which one you choose. Normally, people throw it in the numerator just for consistency. All right, ready for graphing 101 real quick? No, you'll be fine. There are 3 forms of graphing. We had standard form. We'll do standard form first. We had standard form, vertex form, and intercept form. And if you recall, I said one of them was easier than the other 2. Vertex form. Vertex form is your best friend. I thought you said no. That's why I was. So standard form is kind of the format that you guys all learned when you first talked about quadratics. That was the form where it was y equals ax squared plus bx plus c. Excuse me. You know, a baseball game yesterday afternoon in the rain. God, so my throat's killing me right now. Where the a, b, and c values were the coefficients. What did the value of a tell you? Do you remember? What was it? Not the y-intercept, which up like a cup or down like a frown. The a value tells you direction. The y-intercept is always your c value. Okay? So your a value, if it was positive, it was up like a cup. That meant your vertex was a minimum. Your vertex was a minimum. If your a value was negative, it was down like a frown, which therefore meant your vertex was a maximum. That's what the a value gave you. What crosses through that vertex on the x-coordinate is always what we call an axis of symmetry. All parabolas are symmetrical about the value of x within their vertex. So we have this axis of symmetry, the AOS, if you will, is always defined by x equals the opposite of b over 2a. So your axis of symmetry is found by using the coefficients. Take the opposite of b, divide it by 2a. That equation is always written as x equals some number. And that way we know that it is in fact vertical. You just say 2. point? Is it a y equals? Is it an x equals? That's why we always say it's the equation of the axis of symmetry is always x equals y. All right. Then you were able to take this value for your vertex. Your vertex was then located at whatever the axis of symmetry was, and y. Now, what you would do was you would substitute in that value of the axis of symmetry into the equation to generate the y. You are giving it an input to have it to find out as an output, because these are all functions. You put something in to get something out. What you're putting in is that value of x where the vertex has to lie, because it's the axis of symmetry. Okay? So if you look at, let's do this real quick, it's quicker. If I flip over to, I think that's a really crappy looking one. Those are terrible. Ah, why not? So if you look at number 7 on the graphing thing, it says y equals 2x squared plus 5x minus 3. And I want to walk through the whole idea of how to find everything. Just label everything out, plot a couple of points. First thing I want to do is identify where my axis of symmetry is. So my axis of symmetry is x equals the opposite of 5 over 2 times 2, which is negative 5 fourths. That tells me my, oh, first of all, is my vertex here a maximum or a minimum? Which is it? You've said them twice at least. It's a minimum. It's a minimum because it's going to be up like a cup because your a value is constant. So we know it's going to be up like a cup, which makes this is a minimum. And I know my x coordinate for my vertex will be at negative 5 fourths. So when you take negative 5 over 4 and you square it, bless you, means you have to square both the numerator and the denominator. What's negative 5 squared? Ah, 25. It's okay. You're getting that. At least you didn't do the finger. You didn't go all to Kenny Matumbo on you. No, not in my house. Does anybody even know who he is? Thank you. Kembe Mutombo was he was the center, right, for the Houston Rockets back in the Jordan era, and he was notorious for just blocking guys' shots, and he would go back and do this all the time. He'd walk around, go, no. And then, of course, Jordan being, like, you guys never really saw him play, but he was, God, he was awesome. But he would dunk on him, and he dunked on him once, and he got him on the ground, he went like this to him. It's just awesome. Anyway, to figure out what my value of y will be, I take that negative 5 fourths squared, and I'm kind of glad I picked a crappy looking one to kind of give you the idea that even though there are fractions, they're still workable. So when I square that negative 5 fourths, you get 25 over 6. Are you okay with that? If I multiply that by 2, I get 25 over 8. Because these fractions simplify. So you get 25 over 16. When you multiply across, this simplifies, and you get 25 over 8. Move that up a little bit. When I multiply 5 times negative 5 fourths, I get 25 over 4. Negative 25 over 4. Now, those denominators really aren't that terrible. What's common between an 8, 4, and a 1? 8. You try. It's okay. At least you know who Dikembe Mutombo was, so I'll give you credit for that one. So I want to create everything here to be in an 8. You okay with that? Yes. So that means I have to multiply the second fraction by, no, just I have to do 2 over 2. that's how you just multiply by a factor of 1. So you get 25 over 8 minus 50 over 8. And now I multiply that one by 8 over 8. So I get 24 over 8. Not bad, because what's 25 minus 24? 1. And what's 1 minus 50? There you go. So your y value, as crappy as this looks, was not difficult to find. Now, 4th, 16th, 8th, that's a little bit crazy. I try to stick with halvesies, maybe even a third. They're a little bit easier to work with than that one was, but they're not impossible, okay? They're not going to be impossible, because once you get that one value, there's your y coordinate. I forgot what it was. Negative 49 over 8. So if I start to think about what to do with the graph here, negative 5/4 for an x value is a little bit less than negative 1, correct? And then 49 over 8 is what? A little bit less than 6? Smidge less, because 48 divided by 8 is 6, correct? Yeah. So maybe here-ish? You okay with that? What's a number to the right of that that's going to be really, really easy to get a symmetric twin? 0. Okay, if I use 0, what's my value for y? Negative 3. Now, that one was 5/4 to the right of it. 5/4 to the left of it's going to be kind of tough in it. So would it be the end of the world if I just used negative 2? What I'm going to try and do for you guys tomorrow is that I will make sure any of your intercept, any of your what do you call those things? Axis of symmetries, they're not like partially between the two numbers, like more skewed to one side versus the other. I try to stick with it at worst, halvesies, because the numbers are cleaner, they become more symmetrical. Does that make sense? Because now if I use the negative 2, I get 8 minus 10 minus 3. Really isn't bad, but the idea is that they might not be perfect. They might not be perfectly symmetrical. But I'm going to make sure that the numbers are workable. I want to make sure that you saw how you sum them through and not freak out if you had to do something with a fraction. Okay? Yeah? I write it all out. I would say list this, give me two sets of symmetric twins and things like that, just like we did in class. Okay? I'm going to stop because I'm running short. I want to make sure I show the other vertex form and the standard form stuff. Okay? My favorite, vertex form. Vertex form was the y equals a x minus h quantity squared plus k. And what was nice about this one is that your axis of symmetry, your direction, your vertex, everything is written out for you right away. It is a super fast way to do it. Where that tells me that my a value still does the same thing, positive a, up like a cup, minimum, negative a, down like a frown, maximum. H and k is my vertex. And then x equals h is the axis of symmetry. When you have vertex form, you're basically done. All you got to give me are a couple symmetric twins. That's what's really nice about this form. Okay? Really nice. Excuse me. So, for example, if I say that we have y equals negative 2 x minus 3, x plus 3, excuse me, quantity squared, minus 2. Can I slide this up? So if I feel bad for the people all in the back, people, I can't see. We okay with this up top here? What direction is this going? Down like a frown. That means it's a maximum. So right off the bat, we know it's down as a maximum. Where is the vertex? -3, -2. Very good. What's your axis of symmetry? -3. Value here. Because remember, the axis of symmetry is always located at the x value of your vertex. Always, always, always. And that's why this form is awesome, because you don't have to map. You just have to remember. Okay. So as you go through this, we have -3, -2. Now it's just picking points. The next point to the right would be -2. What's -2 plus 3? 1. What's 1 squared? What's 1 times -2? What's -2 minus 2? See how easy this is now? And then that means it has to be here. And then if I use 1, what's 1 plus 3? This would be -1. I'm sorry, -1. 2 squared is 4 times -2 minus 2. So here-ish. Pick the next numbers to the right or to the left of your axis of symmetry. And that'll always get your symmetric twins. Always, always, always. Okay. Vertex form is awesome. It's quick, it's easier. It makes everything so much simpler in the long run. The last form is that intercept form. And that one was also, I believe, new to you guys this year. But as you started to think about it, intercept form was kind of just like factoring and plotting it via the zeros. That's what intercept form is. You're plotting your via the zeros of the function. So as we get into that, the generic form was, let's see, the intercept form. Y equals a x minus, we use p and q, correct? Where p and q are zeros, x intercepts, in case you forgot that name. With intercept form, worst case scenario here, well, I'm sorry, not worst case scenario. What you had to find with intercept form is that they're basically giving you your first set of symmetric twins. What occurs halfway between every single set of symmetric twins? The axis of symmetry, which lies up that the vertex goes through. Okay? So if I use a quick example here, let's just say y equals 2x plus 5, x minus 3. Add what together? Correct. Let's wait and see if you can say that. Very good. So this tells me, first of all, my a value is what? So what direction is it going? First x then is a minimum. It's a cup. So your a value is positive. You're going to have a minimum. We know that our zeros, who's up here, our zeros will be located at -5 and +3. The halfway point of -5 and 3 then is our axis of symmetry. What's -5 plus 3? -2, then what's half of that? So what you're doing here is you find the midpoint. You take -5 plus 3, cut it in half, you get your axis of symmetry at -1. Yep, because you're finding the zeros. Okay. So from there, you would take that value of -1 and do what with it? Yeah, just go right back in. Because now you know your vertex has an x-coordinate of -1. So what's -1 plus 5? That's okay. So we have 2. And then -1 minus 3. -4. So that gives me a vertex at -32. So if I'm going to plot that, about there. It's whatever. I don't know. One of the things that happens, the further away your zeros are on the x-axis, that means the further away your vertex is going to be from it. So I just pick numbers that I knew would divide out quickly. So if I know my vertex is there, I need to get one other set of symmetric twins. So what number is really, really, really close to our axis of symmetry? 0. Okay. What's 0 plus 5? What's 0 minus 3? What's 5 times -3? And what's -15 times -2? -30. So I have an ordered pair, then at 0, -30, and then at -2, -30. I'm not going to mark it with flooring. I really am. I'm not going to draw the lines, though. I draw the line at drawing lines. I feel that. I can sense that. I know it was. I know it was. So the idea here is then obviously the last little bit is factoring. When you're factoring stuff, guys, remember multiply the tails, add to the middle. GCFs are always your best friend. I apologize as I was looking at when I was looking at the quick graph, the function stuff here. It's that number 10, 10x squared, 46x, and 21. That's awful. I wouldn't make you do something that bad. Honestly, that's really bad. Like really, really, really awful. But the intercept forms they have there are terrible. 5/3 for a 0 kind of sucks. I probably wouldn't do that. I'd make sure it's at least a half-z. I wouldn't make it. I'm sorry, 3/7. I would always keep things at worst half-z's. I try not to do anything weirder than that. Solving equations. Remember, you're working backwards. Oh, I know. If you look at number 40 on the solved equation, I think that's kind of what you were talking about earlier. What one of them was squared and one of them wasn't. Number 40 on this one here does this. X plus 2, bless you, 20 squared plus x times x minus 3 equals 1. In order to solve this one first, you'd have to FOIL everything out and distribute my like terms. You'd get x squared, 4x, and a 4. X squared minus 3x minus 1 is 0. Brought that over real quick. Combine stuff through, we get what? 2x squared plus x plus 3. What times what? 6. You add together to get 1. Nothing. It's not factored. No, that's not factorable. Then there are no real zeros. We can't factor it. I'll show you how to answer. I'll show you guys next week how we solve this one, because there is a way. But isn't a double imaginary number just 2 imaginary numbers? And if you square an imaginary number, isn't it just -1? But if I fourth an imaginary number, 1. Crazy. Yeah, well, I know that, fellas. You're fine. I know that. I knew that. I'm not worried. Okay. All right. If you guys got questions, make sure you swing through Flex or stop by first.